Today we're going to look at characteristics of functions. All right, so as we always start, here's our standards, and here's what we need to be successful, our success criteria. All right, so we need to be able to estimate intercepts of a graph of a function. We need to be able to approximate when a function is positive, negative, increasing, or decreasing. And we need to be able to sketch a graph of a function from a verbal description. All right, some key vocabulary that you need to know. An x-intercept of a graph is the x-coordinate of a point where the graph intersects the x-axis. It occurs when y is 0. So if you look at the graph here, your x is your horizontal axis, and if you have a point A0, A would be your x-intercept. A y-intercept of a graph is the y-coordinate of a point where the graph intersects the y-axis. It occurs when x equals 0. So again, y is your vertical axis. So you have a point on your vertical axis, your y-axis here of 0, b. Then your y-intercept is equal to b. B would be your y-intercept. A would be your x-intercept. You can see A is in the x position and B is in the y position of the ordered pair. And then you can see the other is 0. All right, a function is increasing when its graph moves up as x moves to the right. A function is decreasing when its graph moves down as x moves to the right. The end behavior of a function is the behavior of a graph as x approaches positive infinity or negative infinity. All right, this kind of helps you visualize what's going on. So positive, negative, increasing, decreasing, and end behavior. A function is positive when its graph lies above the x-axis. So you can see here's the x-axis. When it's below the x-axis, it's considered negative. When it's above the x-axis, it's considered positive. Increasing is when it moves up from left to right. So if it's going up from left to right, this is considered increasing. If you're going from left to right and it's going down, that's considered decreasing. All right, your end behavior talks about what happens at the end of each function. So the left side and the right side. So the end behavior of a function is the behavior of the graph as x approaches positive infinity and negative infinity. All right, so positive infinity would be this side, okay? Negative infinity would be this side if you're talking about your x's. So as x goes to positive infinity, as x goes to the right, what happens to y? Well, in this case, it goes to positive infinity as well. You can see it's increasing with an arrow, which means it's going to continue in that direction forever. All right, now, as x goes to negative infinity, so this is your negative x's. As x goes to the left, your x's get smaller. So since it has an arrow again, we're going towards negative infinity. What happens to the y? Well, the y is your vertical. It goes up or down. In this case, it's going down, so it's going towards negative infinity. All right, so this is an example of end behavior. This is an example of increasing and decreasing. This is an example of where it's positive above the x and negative below the x. This is excellent things to have in your notes to reference back to. All right, example 1, estimate the intercepts of the graph of each function. All right, so we have a line here. It gives us the equation of the line. We can see the y-intercept is +2, and it has a slope of 4/3. That means if we start here, we can go 1, 2, 3, 4 over 1, 2, 3. All right, so we want to estimate the y-intercept here. So if this is -1 and 1, and this is 2, so this would be 1, this would be -1, and this would be -2. So it looks like this appears halfway between -1 and -2. So this would be about -1.5 or -1.5. That would be your x-intercept, okay? So your x-intercept would be -1.5. Your y-intercept would be at +2, okay? All right, for B part, your x-intercepts, here's your x-intercept, your horizontal would be at 1 and 3, and your y-intercept would be at -3. All right, so it's good to kind of write these down. I'm going to pause the video and go ahead and write these down so you have them. Okay, as we mentioned, your x-intercept here would be -1.5, and your y-intercept here would be at 0, 2. B part, you can see that your y-intercept is at -3, and let's see, I forgot a comma here. All right, and your x-intercepts would be at 1, 0 and 3, 0. All right, so you can use a graph to estimate intercepts, but your estimates may not be exact. You can substitute your estimates into the equation to check whether they are exact. All right, for this example here, it would have no x-intercepts. It does not cross the x-axis. This is a horizontal line at y equals -2.4, so the y-intercept would be at -2.4. So no x-intercept, y-intercept -2.4. This graph looks like it goes up and down, so it has some curves here. So it's going to have 1, 2, 3 x-intercepts. So if this is -2, this would be -1. So it's going to have an x-intercept at -1, 0, and +1. So 3 x-intercepts. And then it's going to have only one y-intercept. Again, it's a function, so it can't cross the y more than once or it wouldn't pass the vertical line test. And the y-intercept is at 0. So I'm going to pause the video and write these down for you so you have them. All right, so to reiterate, for this example, it does not cross the x, so it's no x-intercept. The y-intercept is where the horizontal line goes to y at -2.4. The x-intercepts here are at -1, 0, and 1. The y-intercept is at 0, 0. So that is an x-intercept and a y-intercept since both the x and the y is 0. All right, math practice reasoning. Can the graph of a function have more than one y-intercept? Okay, I think I touched on that, and the answer is no. If it has more than one y-intercept, it would not pass the vertical line test, so therefore it would not be a function. Can the graph of a function have an infinite number of x-intercepts? Yes, because it can go up and down, up and down, up and down. It can have an infinite number of x-intercepts and still be a function. So later in your high school career, you'll see things like the sine and cosine function. That's a good example of this. All right, describing characteristics of graphs. So we're going to look at example 2, approximate when the function is positive, negative, increasing, or decreasing. Then describe the end behavior of the function. Okay, let's first talk about positive and negative. All right, if it's above the x-axis, it is positive. So this graph is positive for all x less than 0. It's positive from 0 to 3. And then it is negative for all x's greater than 3. Okay? All right, let's look at this one. This one is negative for all x less than 2, and it's positive for all x's greater than 2. And for this graph, it stays above the x-axis the whole time, so this graph is always from -infinity to +infinity, it is positive. Okay, so there are no negative values here. All right, let's look at increasing or decreasing. All right, so it is decreasing from -infinity to 0. Okay, and then it is increasing from 0 to 2. And I'm looking at the x values here. So from 0 to 2, it's going uphill, so it's increasing. And then from exit 2 and beyond, it's decreasing. So decreasing, increasing, decreasing, and you determine that by the x's. Okay, so decreasing less than 0, from 0 to 2 increasing, and all values greater than 2 decreasing. This one is increasing the entire time. So it's negative, then positive, but the graph is always increasing. All right, this one is always positive because it's above x, but this one is always decreasing because it's going down. So this one is decreasing across the whole x So from negative infinity to infinity. All right, then it says describe the end behavior. All right, as x goes negative, y goes positive. So as x approaches negative infinity, y approaches positive infinity. All right, as x approaches positive infinity, y approaches negative infinity. All right, for this one, as x goes to the left, it's going towards negative infinity. Y is also going down, so it's going towards negative infinity as well. This one, as x goes positive, it's going up. So as x goes to positive infinity, y's also go to positive infinity. This one, as x goes to the left, and this is talking about the end behavior, as x goes to the left, x is going towards negative infinity, my y's are going towards positive infinity. And for this one, as x approaches infinity, my y values are approaching 0. So this one would actually be approaching 0, not infinity. All right, I'm going to take a second and I'm going to write this information down so that you have it for your notes. All right, I had to move these around a bit to get all the answers on here, but as you can see, positive and negative, so the function appears to be positive when it's below 0, and again from 0 to 3, which is what I said before, and then it appears to be negative for all x's greater than 3, so that's how this would be represented. Increasing and decreasing, same kind of thing. It's going to increase when x is less than, the function appears to be decreasing, it is going downhill. It is decreasing from negative infinity to 0, which is also written as x less than 0, and it's increasing from 0 to 2, and then decreasing again for all x is greater than 2. And then here's how your end behavior would be written. So as x goes towards negative infinity, y goes towards positive infinity. And as x goes towards positive infinity, y goes towards negative infinity. I usually put my x's first, but in the textbook, they go back and forth. So it doesn't matter what the order is, as long as you know that x negative is to the left, x positive is to the right, y infinity or y positive is going to positive infinity is going up, and going down would be y is going to negative infinity. All right, here's the answers that we talked about for these two examples as well. So make sure you've got those in your notes and you understand them. If you don't, please reach out and ask questions.